Hello. In today's demo, we're going to show how developers and service owners can equip other engineers, whether that be operations engineers or other developers, with mechanisms to help them support their service. The title of today's presentation is Service Ownership and Runbook Automation: Help Others Help You. So let's take a look at this e-commerce platform as an example for today's demo. Customers can browse products, add the items to their cart, place their order. They might see recommended products that they might like. They'll see ads for discounts, so on and so forth. This app is made up of roughly a dozen microservices, and we can see the dependencies between them on this diagram and the flags for their different SLAs as well. And on this slide, we see a few of the service owners for a few of these services. And so let's say that this team has moved to an operating model of on-call rotation, or perhaps there's an operations team that are typically the first responders for many alerts. In either case, it's fairly common for individuals to be paged about incidents for services for which they are not the service owner. And as a result, many incidents are escalated to the service owner because they have the most familiarity with the underlying code. And though it helps to get the expert's eyes on the issue to help resolve issues quickly, there are times when it would be faster if the initial responder had mechanisms at their fingertips to attempt remediation immediately. So let's look at an example of a scenario where Rachel, who owns the recommendation service, is the first responder when an incident occurs with the payment service that will impact the checkout service. And we'll see that this payment service depends on some third-party APIs, and this dependency is less familiar to Rachel. So back in our e-commerce platform, people are shopping and normally things are behaving as expected. So let's see what happens when one of those third-party APIs that the payment service depends on changes or goes offline. And so in today's demo, the third-party API will be played by our handy API gateway. So we'll go ahead and disable that. So at first, things appear to be normal. People are still browsing and checking out. Then eventually, evidently, when we try to check out, we can see that the browser is hanging. Interestingly, because of the architecture of this platform, right, people can still browse items and see ads, see recommended products. They can add items to their cart, but when it comes to checking out, they're unable to. And so back in our diagram, just to provide clarity for what's going on in our scenario, Rachel is on call, and now she's going to be paged by an issue that the checkout service is not performing as expected. And so in our platform, an error occurs and tickets start to get generated, but we've been monitoring the service using synthetic checks in New Relic. And we can see that New Relic has picked up an incident for this synthetic check, which has generated an incident for the checkout service in PagerDuty. So Rachel is paged via PagerDuty and she looks at the incident details, and New Relic has provided a number of details about this incident, all fairly generic, mostly pertaining to the synthetic check itself. In the notes section, though, we do see that recent pod logs have automatically been added. When we look at the timeline, we see that this note was automatically added by Rundeck. And so this was set up by the service owner of the checkout service, such that when issues do arrive with this service, the first responders already have details at their fingertips that might point them in the direction of the underlying issue. In this case, we don't see anything that stands out So what Rachel is able to do then is invoke a custom action called dependence diagnostic, also set up by the checkout service owner. And it grabs diagnostic data from all of the services that the checkout service depends on. So we'll go ahead and invoke that. We can see on the timeline now that this action was invoked by myself. When we refresh the timeline, we now see that real-time statuses of the services that the checkout service depends on have been posted to the timeline. And we can see that the email service is running and the shipping service is running, but the payment service has been terminated for some reason right now, just defined as error. And so Rachel will go and take a look and see if there's anything wrong with the payment service. As a matter of fact, we can see that PagerDuty has picked up a related incident also triggered by New Relic, this one pertaining to the payment service. And so our first responder, in this case, Rachel, is fairly confident that the underlying issue has to do with the payment service. On the payment service, same setup in that when the incident is created, Rundeck automatically posts recent error logs to the timeline. And we see that there's a message here for failure, and this might be telling us that there's a failure with some third-party API. Either way, Rachel will again go check to see if the service owner has equipped her with mechanisms to pull more diagnostics or attempt remediation at this issue. And there's this handy no third-party APIs custom action, which, as shown in the description here, will redeploy the payment services pod with the third-party APIs disabled. And so what that allows Rachel to do is attempt to fix this issue without escalating to Paul. So we'll go ahead and invoke that. And again, we can see that this custom action was invoked by myself. We'll go ahead and refresh the timeline. This might take a second. And now here we see, again, Rundeck has added a note that it's redeployed the Kubernetes job for the payment service. And in the environment variables section, we now see that the third-party APIs says no. And so what this has done is it's redeployed this pod, but with third-party API dependencies disabled. And we'll go back to our e-commerce platform. We'll try to check out. And now we see that we are able to successfully place our order. So in this example, we demonstrated how a service owner like Paul was able to equip other team members with mechanisms to help him in supporting his service and operating his service. In this case, Rachel, who was unfamiliar with how the third-party APIs were used, was able to safely turn them off by using an automated runbook created by Paul. This meant that Rachel was able to apply a short-term fix without escalating to Paul. And the next bit, we'll look under the hood and see how Rundeck executes this automated runbook created by the service owner and see how Rundeck interfaces with the other platforms and tools in your ecosystem. Thanks.